Right, and welcome back to our second session where we will continue to close off this question 35 and hope that Kinesia joins us as she promised to join us 1 hour late, which should be any time around now. Right, so we were working on the VAR computations. We got to realize that we were given the standard deviation in the question and it was 400,000 euros. So that was the standard deviation, the value of n. How many years are we looking at? Could somebody let me know in the chat? N was also equal to, excuse me, right, great, and everybody got it, 5 years. And of course, we'll be finding the square root of that. And the only thing to give us any bit of trouble is the value of k now. So k is what I could call the z value, which is also known, well, I'll use common z, which is also known as the ND1, is it? Yeah, the ND1. All right, as we do the Black-Scholes model, right? Oh, there was another symbol, just slips me. Oh yes, Anita, that's what I'm describing now. So this is the what I like to call the z value, or it's the ND1 value, and it is from the standard normal tables. So this is where we'll need to go to the standard normal tables and find that. So a little definition again of it before, it is k is the number of standard deviations. Let me scoot around here so we can all see what I'm typing. The number of standard deviations for a given percentage level of confidence. So further explanations could nicely be found on page, let me get that page back, 169, 170, somewhere thereabouts. Yeah, on page 169. So if you look at page 169 in your manuals, we will find section 2.2 value at risk. And in that little section, one paragraph is one line, then the second paragraph, the third and fourth paragraphs nicely piece together what the K is, right? Or, well, actually, that they're explaining what the VAR is. All right, so if that's the VAR, we need to get to the K value, which is basically on the other side with that graph, so to speak. So while they indicate the VAR value, that little graph actually I'm thinking is more so indicating the K value. So the K values is that number of standard deviations which we are going to find from the normal distribution tables. All right. So since the definitions that they have there of K is not how we like it, I would proceed further to type it out here again. So from the standard normal tables, the K value is what I like to call the headings of the required table value. So two things I'm taking note of here, the headings and something that I'm calling the required table value, right? So let's go about dealing with that. So step one really is to identify the required table value. Right, so we do this. To do this, we take, I could say that is equal to 0.5 minus open brackets 1 minus the level of confidence. Is there another way I could put that? 1 is supposed to be a minus here. 1 minus the level of confidence. So that 0.5 minus, actually, let's see if there's a better way I could say that. That's 5% and that's 50%, and then that's 95%. So, all right, let me try and explain it on the side here, what I'm mumbling on about. Right. So we have your standard normal graph, which looks like this. The area underneath the entire graph is always 1. And we are only given areas under the graph for half of the graph. So on the standard normal tables, the standard normal tables give us this area under the graph. All right, so all those numbers on your tables, I could direct you to the table and I will bring one up on the screen shortly. So your table is on page 507, your standard normal distribution table. And there you will notice the two things I mentioned. The table has headings going across the top, as well as a heading in the first column. So the table values is this area of, again, the standard normal graph, and this area here. I should use a different color for that. Oh, so this area here is what I call the table values. And to find the required table value, I just came up with that sequence there of taking half, which is 1/2 of the area, minus 1 minus the level of confidence. And I'm thinking now, can I do that in a shorter method? As the whole of the area represents 1, so that's 1. Half of it will obviously be the 0.5 that I was using before. I'm trying to identify this unshaded region here. So that's the value I'm looking for. 5 minus 0.45. I think 95 minus 0.5, that would get me it. Yeah. So I could shorten this in terms of taking the whole one and subtracting from that. If I subtract from that 0.5, no. Let me put in a different color. My apologies for what might seem very confusing here. Hopefully it'll make sense very shortly. My arrow is too long. I can't do that. So if my arrow stops at this red mark here, which is what we're trying to find the key value of there, so that is my confidence level. Which, if you refer to your question, we were given 2 confidence levels. Could somebody tell me the first one? Give me the first. Yes, thank you very much. So instead of going all the way to 1, the first confidence level is 95%, or in other words, 0.95. So to get to the number, which I'm calling the required table value, instead of doing that longer working of 0.5 minus 1 minus the level of confidence, I could also now switch that to say simply 1 minus the confidence level. No, sorry, mistake. Let's redo that. That will now be the confidence level minus 0.5 will give us what the required table value is. Right, required table value. So let's look at my blue arrow. What did I do? I took my confidence level here and I'm chopping off half of the graph, which represents 0.5. Well, half of my arrow, effectively half of the graph here. So if I have the confidence level, which takes me up to this K value that we are looking for, and from the negative end all the way across will be 1. Confidence level stops at the 95 there. If I take off this 0.5, that leaves me with how much? So 0.95 minus 0.5. Let me just redo that in this section here. Let's see, or would be equal to the confidence level minus 0.5, and that will get us equal to 0.95 minus 0.5. Somebody give me that answer. Great, people are following. Excellent. 0.45. Thank you, Anita. So the 0.45 is again the required table value, and that's the area which I outlined in red on the graph. So again, that is a value which is within the body of the table. So once we have this, our next step 2 is to find the required table value in the body of the table. All right, so okay. Kinesia, good night, Kinesia. Great that you can join us as promised. We're just going through the VAR calculation, and we're at the second stage where, having found the required table value here, we are now going to the table to find it again. So required table value in the body of the table. So how do we do that? Let's see, I need a picture of the table to drop in. Let's see if I could find one from the kit. Could my kit help me out and give me a set of tables? Let us see. No, doesn't seem so. Try the end. Ah, yes, I saw something there. Yep, got it. So all I need is a picture of this 1.6. Need to go down to 1.6. There we go. Picture of that. Come back here, drop this in here, and make it smaller for a bit. Put it so that I only have what I need. Make my knife clearer. smaller. Back to where we were. 1.736. That's a little tricky, Anita. Where did you get that from? All right, hold on. Let's get it done together. So now that I have tables over here, right? We're saying we're trying to look through the tables to identify. Nope. You're not starting with the extremes, or you're not starting with the headings. That will be stage 3 or step 3. So as I mentioned in step 2, let me go back here. Step 2 would say to find the required table value where? Inside the body. So we are not looking on the edges, as Anita pointed out there. We are looking in the body of the table. So let us go looking in the body of the table. So in the body of the table, we would notice that the table starts off in the top right-hand corner. So we're not using the top row, which I call the heading. So let me label the headings. So the top row is a heading, right? So that top row is heading, as well as this first column is a heading. So we're not using those two, right? So the first, my highlight's not staying. Okay, it's staying for now. The first number is 0. And as you go down, the numbers get larger, as well as while you go across the table, the numbers get larger as well. So we are looking for 0.45. So in our numbers, coming down first, let's start in the left column, coming down, we have 0, 0.1, 0.2, 0.3, and as we get down to 0.4 here, we have lots of numbers with 0.4. But what's our next number after 0.4? And Natalie came up with this strange number again that Anita also found. All right. Hold on, ladies. Follow what I'm doing. So I'm looking on the inner part of the table, not using the two headings which I mentioned. Natalie, are you with me? We're not using the headings at this stage. The headings are going to be used at the end. Right? So that's 0.1745. Okay, I see what you all did. And please don't do that again. Listen to what I'm saying. So if you found your 0.4 in the heading, which is not what I told you to do, and found your 0.5 in the heading, which is not what I told you to do, and you come down and you come across, that's why both of you all are shouting 0.1736, which is wrong. So listen, please. We are starting inside the table. We are not starting at the heading. You are going to end by looking at the heading. So we are going to start in here in the body of the table. All right, so this is opposite to what we did. Now Anita is saying something very nice. So this is opposite to what we did when we did the ND1 values, okay? So here we are starting with the inner parts of the table, and as Anita found it, looking down here we have the 0.4, but we're looking for 0.45. So here we have numbers, but if we try to do 1.7, you realize it's larger than 1.45. So we have to start with the 1.6 row going across. Is everybody clear with that at this stage? So the number that we're looking for, that we're going to end up with on the headings, is 1.6, getting us 0.4. And here we have 0.45 with almost nothing next to it. All right. So this is where we can say what number is on the top of that. That is 6. So, sorry, that's 5. Looks like a 6 because the numbers are so small. Right. So 1.6 is a number from after you found this in the table. We are reading now outwards to end up with the values of the column headings and the row headings. So you're reading outwards, not inwards. If you read inwards, Starting with the outside and read inwards here, those would be wrong. What we want is to read outwards to get up to that. 1.65. Is everybody clear there? So you find the value here first with the green highlight, then you read outwards. Read outwards up there to find the 5. Kinesia, how are you? Did you just follow that? In terms of once we found the 0.45 on the top corner of the left-hand side of the screen, to find that 0.45, look inside the table, you're not dealing with the headings, and then you find that and you move outside to read off what the heading values are corresponding to the 0.45. Now, equally, you could have chosen, Natalie is asking, why not 0.4554? All right, Natalie, very easy to answer that. We are looking for our required number is equal to 0.4500. So Natalie's question is about looking at 0.4554, which is 2 digits off from the 0.45 that we're looking for. All right, so there are lots of numbers that start with 45, but we want the closest one, which is closest to 0.4500. All right, Natalie? So lots of numbers start with 45, but we're looking for the closest that we can get. Actually, if we had chosen the one just before it, if we had chosen 0.4, let me write that to the top. If we had chosen 0.4495, no, 46 is too large. Would that not be equal to 456? 4495 is equal to a K value of 1.65, if that's what Anita was trying to say, not the 0.46. So we don't want 0.46. Oh yes, you were trying to explain Natalie's number. Yes, Natalie. Yes, Anita should be right there. Are you following what she said? Natalie? Anita's pointing out if you really look at that, the table heading values corresponding to that, or in other words, the K value corresponding to that, let me write that in. The K value corresponding to that would have been, hold on, 445. No, Anita, how did you get that? 4554. Where is that? Where did Natalie find that? 455. That's 5, 4, 5, 5, 4. It's way down here. That's 1.70, Anita. That's just where my arrow has ended. So that would give us a K value of 1.70. You following that, Anita? 1.70. So yeah, that will be here. So going outwards would be the 1.7, going upwards would get you the 0. And yeah, no, that's way off. So again, the only other option that could have been acceptable was this one right here, because 4495 is only 5 away, just like 0. Let me take off this now. Just like 0.4505, right? So these two numbers, which are the two acceptable ones, 1. Hold on, my first one is what? Not 1.65, that's 1.64. 195, yeah. 195 is 1.64. So getting that. 64. And so it's between 1.64 and the k value of 1.65. Those two are the acceptable outcomes or results of looking for your k value. I see. All right. So, yeah, great. Thanks for that, Anita. Everybody okay? So, don't go too far off the beaten track. Try to get as close to your required table value that you can. Now, actually, in this instance, where our exact value that we are looking for is 450, if we notice, it's exactly 5 away from the top and 5 away from the underneath number. What we can do here is a bit of interpolation between these two numbers. Now, in the exam, you could stop here. But again, if you have the time and you want to figure out that halfway between 64 and 65 is how much? What's halfway? Well, no, not one. Let me update the numbers. If we call it 164 and 165, what's halfway between these two? Try again, Anita, come on. It's 3 digits you're working with. So that's now, getting closer. Let us now put the number to 4 significant figures. Or again, let me add on the 0 here. 1640 versus 1650. What's halfway between those two? Right, the 4 digits for me. 1, I'll start you off, 6, something, something. Excellent, 1645, right? And if we put in the point, then we're back where we started. So 1.645 is actually directly between the 1.64 and 1.65. But again, the examiner stated that they want to stress you with all of that. Once you choose either the 1.64 or the 1.65, both of them will get you to the same place. All right? So is everybody okay here? All that action for finding the value of k. Now, again, 2 of those k values were given on page 169 or page 170, somewhere thereabouts, and you could have memorized those, and one of it was the same 1.645, and either or, we can now go back to where we were and finish off with step 3, which we just completed. So I'll just note for you step 3, which was basically that. Step 3 would be to identify the k value as the headings corresponding to the required table value. Right? So again, move outwards. So moving outwards, identify your headings. Again, let me put headings in inverted commas here, very important. So k value is the headings corresponding to that. All right, just give me 1 second. Let me plug in the computer before the battery goes. Okay, and we are back. So, having identified the k value, We have 10 more minutes. Let's see. We might still need a third session after that, unless we can speed up to do our our explanation. So now that we have K is equal to, which one you're going with? So we have three choices. We have the interpolation, which we sorted it, or we have the lower approximation or the higher approximation. 1.645, 1.64, 1.65. Somebody type a value. Choose one. Come on. Somebody be brave. Pick one for me. Doesn't matter. Now we have two choices. I'll go with the first one since Anita was first on draw. So it doesn't matter. 1.65. Again, if you do enough computations in this area, you'll realize that always at the 95% confidence level for what we call a one-tail test, it will always be that 1.645. Right? So that wouldn't change for what we describe as a one-sided test. For that level of confidence, at the 90, you'll be 95% confident that the company will not lose, or the project will not lose at first rate, at first value that we're looking at. That we're about to calculate. That's the VAR value. All right, we'll come back with that with our final statement. So the 1.645 would be consistent with 95% if you wish to use that going forward. So now that we've chosen 1.65, we can find, we now have the three values to compute VAR, which we'll remind ourselves again. Copy that from up above. Here we go. Right. So those three things, we now have the three bits. And PAR is now equal to 1.65 times our standard deviation, 400,000, times our square root. I'll just put this square root of 5. So somebody punch in that for me. Let's see what we get. Probably do the root of 5 first. Why is Anita getting something else there? All right, come on, careful with that square root sign. Let's try the square root of 5 first, Anita. So press your 5, press your root x, and get your 2.236. Then multiply by 1.65, then multiply by 400,000, and you'll get something closer to what Natalie got. Right, very good. So 1,475,804. In other words, 1,475,476,000 as we get around there after thousands once more. So VAR equals 1,476,000. Right, so this would be once more at the 95% CI confidence interval. So we need to get that done a second time. So we're now saying at the, what was the second one we were asked to look at? 90%? 90% CI. Step 1. What is our required table value? Come on. Find table value is equal to CI minus 0.5. Come on, somebody could work that for me. Excuse me. What's our CI as a decimal? We are now working 0.4. Very good. Use another 10. All right, so we're now looking at 9% CI, which would be 0.90 minus 0.5. That leaves us with 0.40. Now that we have that, step 2. Find required table value in standard. How come? Well, what's the question, Natalie? We're just redoing the steps because the question asks us for both the 95% CI and the 90% CI. Okay, great. So going to our tables, and after we found that, then we can go to step 3. So 0.40. What's the closest thing we get to 0.40? Somebody could shout out a number at me. .29. Okay, Anita's speeding there. I wanted the number in the table. So the closest number in the table to what we're looking for is 0.3997. Hold on, Natalie's saying 1.35. 1.35, Natalie. Yeah, it's a bit off, right? So as we could identify here, 3999, etc. It's close to 3. It's close to 4. The only thing above that would be 4 point something. So 3997 is the 4 decimals 3 digits away, and the 4015 is 15 units away. All right. So are you okay now, Natalie? That's okay. This is a place to make the mistakes, not the exam. Right? So with this, okay, I need to choose the other one. That's fine, you know, Anita. If you choose the other one, then that's close enough, right? So again, because it's not exact, we will basically be okay. So you don't use that as any bother. So that's a 1.2 going across. And if we use my one, you'll have the 0.8. So the K value is 1.28. Right. So that's that. Let's go back to our bookings. Any queries with that process, Kinesia? Was that painless enough?